continue practicing solving quadratic equations. We have four methods that we can use. Some of them are appropriate for problems and some are not, so we're just going to walk through the process. So the first one we have is square rooting. Again, if you look at your sheet, it says this only works if there is no bx term. Good, we have no bx term. So the steps that we would use to solve using the square rooting method would be to isolate or get this x squared by itself. So in order to isolate or get it by itself, that just means, in this case, subtract the 50 from both sides. So now we have x squared all by itself on the left, and it equals a negative 50. Okay, so we learned at the beginning of this unit that in order to solve for a square root, you square root both sides. So square root x squared, that means you would have to square root the negative 50. Whenever we square root and we're solving, remember there always has to be the plus or the minus because we're solving. So now we have x equals plus or minus the square root of negative 50. And as you learned at the beginning of this unit, whenever you see a negative under the square root sign, you can pull out that I term, or that I, not term, but I option. So now we have plus or minus I square root of 50. When we were breaking apart square roots in this chapter, we said that a factoring tree may be a great option. So 50 can be broken apart into 2 and 25, and then 25 can be broken apart into 5 and 5. 5 is our pair. So again, the way that we write this would be plus or minus the 5, then the I, and our only single term stays under the square root, so we have square root of 2. So my answer for this problem would be x equals plus or minus I, the square root of 2. So then we go through and we say, okay, factoring worked. Or sorry, square rooting worked. Does factoring work? Well, if I'm going to factor, when we factor, we always have to ask ourselves, first, is there any GCFs? There's no GCF. The second thing we would ask is, do we have a quadratic trinomial? And because we only have two terms, we don't have a quadratic trinomial, so we cannot factor. The next method that's on our list over here is graphing. Again, if you look at your sheet, graphing only works when the solutions, when the x equals, are real numbers. And since we have an I in this term, we can't use graphing because the solutions are not real. So factoring doesn't work, it's not a trinomial. Graphing doesn't work, it's not real. Now, quadratic formula should work for every single problem. So as we're going through this, let's try the quadratic formula next. If we're going to use the quadratic formula, we should first be able to identify the A value, which is 1. The B value has to be 0 because there is no B term, and the C value here is a positive 50. And then we're going to substitute that all into the quadratic formula. Again, it is very important that we substitute and that we recognize that B is a 0 term. Now we're going to simplify. So we did that. Again, 0 terms cancel out, and now we have this plus or minus I term again. So we have to, again, when we're here, plus or minus, negative sign, so you have to pop out an I. So square root of 200 over 2. Again, it may help to break apart 200 using your factoring tree. So 2 and 100. 100 could be 10 and 10, 2 and 5. Again, there's no really correct method for doing this. So I would have a pair of 2's and a pair of 5's. So that would look like plus or minus, well, 2 times 5 is 10. The only single that's left is the 2 over 2. And then because there's only one single term on the top, we can divide here, and so we get plus or minus 5I square root of 2 again. So we were able to complete this by square rooting and by using the quadratic formula to find the two answers for x. A positive 5I square root of 2 and a negative 5I square root of 2.